Well, let's go ahead and start. My name is David Hayes. This is assembly language programming. First thing I'm going to do is go into the syllabus. Um, it's possible when you go into Blackboard, especially if it's your first time going to Blackboard, you have to finish an orientation. Um, so you have to go through, answer all the questions. I understand it's fairly short. And once you successfully finish the orientation, then your classes will appear. Now here's the link for assembly language programming. I'm going to the syllabus right here, which is into the start here. And you see the Word document. And click that. There, I clicked it. Okay. My phone number's there. They fixed the my message light, so I pretty well know when I have messages now. So I feel comfortable with giving that phone number out. All messaging should be done through Blackboard. If you send it to my regular email, it might get mixed in with a lot of junk email I get each day. Still working on the office hours. That should be approved probably first part of next week, if I had to guess. Purpose goal of the course. This course is designed to provide an introduction to assembly language programming. These concepts provide a foundation for future studies in courses related to engineering and computer engineering. Objectives of this course: upon completion of the course, the student will be able to explain a computer's instruction set, change binary digital data, design assembly language solutions, write assembly language programs, including various programming elements, and integrate assembly language with a higher level programming language. Let me bring up Kali here. Let me go to academics. Natural science and math. And here's a pre-engineering. You'll see these Wichita State University 2+2 pathways. That's where this course and others have come from. For example, if I go into the computer science link here, this is what we see. Wichita State came to us, and they said that people coming out of our program didn't have the necessary classwork in order to be as successful as they should be when they get to WSU. Oftentimes, they were having to take an extra year because they just didn't have the preliminary classes. And so they said it was vital that students going through these pathways have the appropriate courses. And you see for computer science, we have the assembly language programming down here. You'll notice some other ones. Let me go ahead and mention them. The math 4445, engineering probability and statistics 1. That's offered at Mulvane currently, and it's only offered in the spring semester. We have and these are the ones that Wichita State told us to add. So the rest of these we've already had. We had PHS 4555, engineering economy. This is offered in the fall semester, and it's offered at Mulvane. And then we have the CIS 1894 Introduction to Digital Design, and that's offered in the fall also. and that's offered at Wellington, and it's broadcast over the internet, so you can attend the lecture from anywhere. Um, the lectures are recorded, which I'll talk about here shortly. So even if you cannot attend during that time, you can watch the YouTube video at any given time. We've had C programming around for quite a bit, and that's one of them that you need to have taken. And then you can look at these other classes. Those aren't new from what, of course, C programming is not new, but these aren't new from what Wichita State told us that we had to offer. If I come down here, you'll see some of these are different. Go in electrical engineering. C programming, engineering probability and statistics 1. Trying to find Introduction to Digital Design. Here it is, Introduction to Digital Design. That's kind of a universal one that you need in a lot of these different pathways. Not every one of them, but that's one that you'll see a lot. The assembly language programming, I doubt if you'll see it in this particular one. That's not required in every pathway. I would encourage you to go out here and look. You want to plan, if you're going to WSU, you want to plan it around one of these pathways. You don't want to plan it around just a generic pre-engineering degree. These will better prepare you so when you go to Wichita State, you're not having to go an extra year and a half. Okay, so that's the background of where this course came from. It's interesting because we don't usually have a 4-year college approach us like that and tell us what classes we need to add to our curriculum. Oftentimes we have to go to them and request a meeting and try to get a partnership set up. So now we weren't alone. Wichita State met with many different schools because their goal is people should be successful when they go to Wichita State. And they weren't seeing that. They're seeing too much time to get some of these preliminary classes done before they could then take the junior level classes. Okay. I'm not going to sit here and read all this to you. Expectations of the class, instructor policies. Student is either expected to either attend the class in person or virtually. If this is not possible, then it is expected the student will listen to all the YouTube lectures. Important information will be given in the video, same as in the classroom. If you do not watch the lecture, then you will miss you may miss important class information. For example, if at the end of class I tell you something's due in 5 days' time, it's due in a week, probably won't put that into an announcement. You have to actually watch the YouTube video to get that information. So don't start watching the video and not finish watching it. That's like coming to class and leaving halfway through or quarter of the way through. You'll miss a lot. Let's see. There's no late work. Textbook. Got the ARM assembly language, introduction by J.R. Gibson. I think it's from Lulu, which means it's a relatively inexpensive book. That is the same book that Wichita State uses. We patterned this entire course after them. Using the same book, all the course competencies are the same. We basically copied everything with their permission. Same with Introduction to Digital Design. Even the labs that we have are the ones that Wichita State does in their class. Our goal is that people would transfer to WSU and it'd be completely seamless. you're used to the same environment, the same tools, the same curriculum here as you would get at WSU in those classes. It's your responsibility to have access to a working computer with reliable internet access, and you should have the ability to install software. It should be a Windows computer, Windows 7 or greater. Course grade breakdown: programming projects are 80% of your grade. Now that may actually even be just questions out of the book. What you'll find is those questions out of the book lead into part of the programming process. Part of the programming process can be the planning, trying to understand data storage. So it won't be 100% programming on that, though it will be a lot. Then a final project / online test, and then your standard 90, 80, 70, so forth. Extra credit, none. Tutoring. There is no tutoring available. I'd be shocked if you go to the tutors and find anybody that can program that has programmed in assembly language. So if you need extra help, you just let me know, and we'll figure out a time when I can get on. Here's a withdrawal date. Like I say, I like to read all that. And then down here's the schedule. There's a total of, I think, 14 chapters in here. So got a couple free weeks at the end to kind of get caught up and maybe adjust schedule a little bit if we see some people are struggling in a certain area. And that's syllabus. I click course content. And here you'll see the Zoom link. So if you want to get on, attend lecture live, you get on here, you click the Zoom class link. Probably you'll be getting on 5 or 10 minutes before the start of class. But if you go ahead and click it early, it's no big deal. It just says waiting for a host. If you cannot get on during this time, this is called synchronous learning, by the way. Same time. It's where we're both on interacting. Asynchronous is when you get on whenever you want. And the instructor gets on whenever they want. And so you may never actually talk online with your instructor. So this synchronous learning session is meant for people to attend the lecture if they want, ask questions if you got a microphone. If you cannot attend during that time, it's not a big deal. I record all the lectures in YouTube video format, and I upload them to Blackboard. Each week, we'll have a folder out here. Within that folder, you'll find your YouTube video link. You'll also find some handouts in some cases, and you'll find projects that have been assigned. Go ahead and go into this week one. Overview of the week. You want to install the Kyle Vision 5 software, if I'm saying that right. Watch YouTube video on how to get set up to run assembly language programs. And then create a Hello World program just to run default code as an step file. So you don't even have to make any changes to it. Now here's the link for the software. I'm going to go ahead and click this. When this comes up, you see down here it says to install the MDK ARM software. Right click on EXE and save it to your computer. That's this EXE right down here. So you can right click on that and save it to your desktop or wherever you want. And then you want to run it. It doesn't specifically say that. But if after you've downloaded that and so forth, then run it. Take all the defaults. That's when I installed it. I just clicked next. I didn't even because I installed it before, but I knew that none of those needed any changes. When it first comes up, it may come up with a screen where it's updating various packages, and go ahead and let it finish that. Now, when you click this link, it'll ask you some information. Your name, email, so forth. It's a free package with what we do with it, but they do want to know who's using it, type of deal. Okay, so you've gone through, you've downloaded this, you've installed the software. Here's a video, and I'm going to play this and stop it at certain places.
Hey guys, so today I'm going to show you how you can set up this
Yeah,
software so you can test
maybe.
your assembly programs in your EC252 class. So the first thing you have to do is download 5 startup and library files that you have to have in order to run an assembly program in that software. So what we're going to do is go to uh, tinyurl.com/keel setup files. I'm also going to put this link and download the files. So these are your 5 files.
There we go.
So go. I'm going to show you how you can set up this Keel UVision software so you can test and run your in your EC252 class. So the first thing you have to do is download 5 startup and library files that you have to have in order to run an assembly program in that software. So what we're gonna do is go to
He's already installed the software, that Kyle UVision, and now he's downloading some additional files. Now, where you'll see that at, if I can find the link. There we go. You'll see a link within Blackboard that says setup files from the YouTube video. And when you click this, it downloads a zip file. And if you right click on this file down here, you can say show in folder. And this shows where it's saved at. Now, I then went and I saved it in a different folder. I created a folder under my C drive, and I called it assembly language. And I'd recommend you create a folder for this. And then I copied my zip file here, so I right clicked on it, did an edit copy, and I came over here and did an edit paste. Then I right clicked on it, and I chose extract all. What that did after I said go ahead and create the folder is it created this folder with my files in it. You see the UVision setup files. If I double click that, here's these 5 files, and these are the 5 kind of important for your developing a program. Now, when you create a program, you need to copy these files to whatever folder you created. For example, I created a folder called Program 1. And then I immediately copied those 5 files here. So you see the .s's. Those are the 5 files I copied. You need those for every project. When you create a new project, create a new folder. So don't put it all in one place. Have them separated like that, and then copy those 5 files in. Okay, so let's go back to what he's saying. There we go.
tinyurl.com/keel setup files. I'm also gonna put this link in the description below so you can download the files.
That's the link to download those
So these are your
five
five
files.
files. So go ahead and download these. I have already downloaded it, so I'm not gonna do that again. So once you download these five files, uh, have them. I put them in a folder named Keel Setup Files, and it's on the desktop. As you can see over here, these are my five. This is my main assembly program file, which I can edit.
Quality of this is lacking a little bit. I don't know if there's a high definition option here. I don't see one, but quality 240. Let's try that a little bit better. 720. There. That's easier to see. So he created a folder somewhere and he dragged and dropped those five files in there. And again, the reason why is because those are ones you need to run programs, and somebody's went through already and figured out what the default should be in some of these files. We'll see that.
According to my whatever program I want to run, and this is basically a startup file. These are two, I believe, these are two libraries that you have to have in order to run a basic assembly program, and this is your Cortex M3 processor file that you that basically you have to have it in order to run. You have to have these five basic files in order to run a basic assembly program. So I have them right now over here. You can have these on your desktop too if you want. So this is done. Just have it in a folder and keep it in the desktop. So once this is done, close it out. Now open your Keel UVision software if you have already downloaded it. So open it.
This actually does sound better when you're running it at home. And let me bring up the same thing as he is. Here's the Kyle UVision 5. I'll double click it. I currently have a project loaded, so I'm going to close that. Well, I'm not seeing a close on here. There it is. I had to click the project and close. So if I didn't close that, close the file I just had. Huh. Let me just do a file, new project. There's project, new UVision project. And save changes, no. Ask me where to put it at. Now you see I got the assembly language file, folder I created, so I'll click that. And it says program 01. I'm going to click new folder and type program 02. So I'll double click that, and then, well, let's try it again. Double click program 2, and I'll put a test in here and click save. And save changes, no. Okay, that closed my old one.
This up. Whatever. I just want training was. So now what we're gonna do is we're gonna go to project and make a new project, new vision, new
That's
vision
what I just
project.
did. Project,
Click on that
Vision project.
and name your project. And I like to save it uh, save it in the same folder where my startup files are. So I'm gonna look for that folder. It's on my desktop. Heroes setup files. That's my folder where all the five files are. I'm just gonna put the project in the same folder.
He's putting the project in
Uh,
all in the same folder as those
and
five
just
files. I wouldn't recommend that. Um, I started doing that last time I taught this last spring, and it was a mess. Because if I changed those five files, if I changed one of the other files, then it potentially screwed up many different programs. So what we're going to do is when you create a new folder, you're going to copy those five files each time. What I mean by that, um, remember I was right here. I was creating a project, and I created a new folder. Program 02. Well, I'm going to go to the setup files, UVision setup files. I'm going to copy these. So I'll highlight them and I'll do a copy. I'll just right click, choose copy. Then I'm going to go back to my assembly language folder here and I'm going to go to program 02 and I'll paste this in. That way you're sure every time you do a project that you got your own set of files. Okay.
Windows should pop up. Now what you have to do is expand this ARM where you see that. Go to Cortex M3 and
Okay, so we'll come down here. You see the arm down here. I'll expand that. Tells us go to ARM Cortex M3, so expand that. And then you see your ARM CM3 down here.
choose ARM CM3 right here. Press OK.
Now this says the Cortex M3 processor is an entry-level 32-bit ARM Cortex processor designed for a broad range of embedded applications. It offers significant benefits to developers, including simple, easy to use programmer's model, highly efficient, ultra low power operation, excellent code density, deterministic, help performance interrupt handling, and upward compatibility with the with the rest of the Cortex M processor family. Hard for me to see. And I click OK. Now here we got some more configuring to do.
And over here you have to choose expand this CMSIS and where you
Expand to CMSIS right here. Now what you're going to see when you expand this, these version numbers are different than what's in the video.
you see core right here, you have to check this, select core.
Okay, now the one they're choosing is one that says CMSIS Core for Cortex M. And so CMSIS Core for Cortex M, that looks like this one right here. So I check it. Now mine is 5.1.2. This one is 4.1.0. So the versions of them are a little bit different, but that's okay.
So that your assembly environment, whatever that is, knows that you're running Cortex M3 assembly program for that processor. So you have to have that checked. Once you check that, press OK, and now you should see this window right here. Now you should see that processor. So you have to have that checked. Once you check that, press OK, and now you should see this window right here with your project. And if you
Okay. So over here, click OK after you've selected that. And over here, you see a project window. He talks a little bit about that.
don't see this project window, you can just go to View right here and select this project window from here. If it's
Okay, so what he's saying is if you do not see this project window here, you go up to your view and you can tell it to view the project window. Also, if there's some of these other ones you want to see, you just do a view on those.
not selected. So now what you have to do is expand this, expand target one, click on this plus sign, and where you see source group 1, now
Let me expand my target first. So I click expand target 1.
we have to add those 5 startup files over here in this source group. So what you have to do is right click it.
So right click source group
add
1. So I got source group 1 here. I right click on it and choose add existing files to a group since they're not new. Now when this comes up, it'll be well, mine's in program 2 which I created, but I don't see my files. That's because down here in files of type, it says C source files. So it's looking for .c. We do the drop down here. You'll see there's a I think that says ASM source file, but anyway, it says .s and so forth. When I change that, then I see those 5 files. If I click the first one, I can hold down my shift key and select the last one. And those are going to be our 5 files.
existing files to group source group 1. Click on that and go to the folder where you have your 5 startup files. Mine is in this folder. It's not showing, the files are not showing up right now because I have to select the correct file type from here, over here. So click on the drop down menu and select ASM source file. Now I should see all my 5 startup files. I'm gonna select these 5 files and click on add.
Okay, so I'm going to go ahead and do that. I got my 5 files selected, and I'm going to go ahead and click add. Now, when I did this before, I didn't appear to do anything, and I clicked add again. I thought, well, what's going on? Why isn't this working? But if you look over here at your source group, you see how there's a plus right here. That means that you can expand and see what's there. So I'm going to go ahead and do a close and choose the expand. And you see your 5 files.
Once you click on add, close it, and now you should be able to see your 5 files in your source group. This is your main file right here if you click it, and I've written.
These are serve different purposes. If I click the core CM3 contents.s, this is what I've set up. You can see not very user friendly. If I click the second one, main.s, This is our main program. This one we're going to be talking about.
A basic assembly program where I move a couple of values into the register, which we're gonna see the result at the end. And these are your two library files that you have to have, otherwise the program's not gonna run. So basically you can use this main file as a template and change the code from here and test whatever code you want. So now this is done. Now we have to go to now we have to change a couple of settings inside the program. So go to where you see target one right here, right click it and go to options for target one.
Okay, so come here to source, or let me see, which one does he on? Target one. Right click. Yeah, let's see what it says.
Go to where you see target one right here, right click it and go to options for target one.
Okay, options.
Right here.
So we'll go to target one here, right click, and there it is. Right click, and you got options for the target.
Go to the output tab right here, output, and select create hex file.
Okay, so we'll go to options, and debug and create hex file. Which one do you click? Output. Okay, so debug information, create hex file. I have to apologize. I'm not seeing very good with these glasses. Got them just recently and having trouble reading the screen here.
Right here. Now go to linker.
So linker.
This right here, linker tab, and select use memory layout from target dialog. Once that is done, finally go to the debug tab.
Okay, so on this one, we just want to simply click use memory layout from the target dialog. And from here, we're going to go to debug.
Right here, and now we're gonna use simulator because we don't have an actual board, so we're just gonna simulate the program. So make sure you click that, use simulator, and click OK. That should be good.
Okay, so use
Now
simulator.
before running the program, this
And click
program right
OK.
here, we have to build all these files. Once you start a project, you have to build all these files. So what you do is right click on target one again and select build target.
Okay, so it says to right click on target one. And I see the build target.
To build all these files. So what you do is right click on target one again and select build target. and you should see over here in the bottom that
Okay, so right click on it and choose build target. Comes up and down here, says there's a 0 error, 1 warning. That 1 warning is normal, so you don't have to worry about it.
your target was built, and you might get a warning too, but that's okay. Uh, so unless you don't have any errors, if you have any errors, just let me know in the comments below. But you shouldn't get any errors. You might get a warning. You get it sometimes. I don't know what that really is. So once the files are built, now you have to go to debug right here, and before running it, you have to start a debug.
Okay, so we just built it. If you come up here, debug, there's a start stop debug session. Comes up and gives you that message there, running with a code size limit of 32K. We won't ever do anything with so big in this class that you need to worry about exceeding that. So you just click OK. Comes up with this. Now once this comes up, notice over here, we got registers and values, and all these say zeros here. None of them say any values. Now if I come up to debug and I say run, then you're going to see some values change over here. This one that says R1, that now has a 4 here, R2 has a 6, and R3 has an A. Now, after you get done running it, you can go in and change your program. Where's that at? Debug. Yeah, I guess debug. And start stop debug session. Thought it was somewhere else. But now, if I double click main, this is back to our main code. Let's talk about this code a little bit. We're going to be talking about assembly language a lot. It says move R0, comma, pound 0. Move R1, comma, pound 4. Move R2, comma, pound 6. What this is doing is it's just adding numbers together. Okay, I'm going to add 4 and 6, as if I didn't know what that's equal to. Now, escape out of that. Then I'm going to go to Visual Studio. We'll talk about this here briefly, but I just want to show it. If I wanted to add 2 numbers together, 4 and 6. Come here, do a file new, choose project. Visual C#, and I'll go into Windows Form app. Leave that as default. In case you're wondering, you don't have to do this Visual C# portion right here. I just want to demonstrate what type of language this is. Resize that a little bit. I'm going to drop on 2 text boxes, a button, and a label. Actually, we put 2 labels on there. Okay, I'm going to put my numbers in here, 4 and 6. Click this button, and it's going to add them together. So let me change this so it says something different. This is going to be our sum, or we'll add them together. Now I could give these names so it'll be more user-friendly to use in your program. The first one I'll call TB underscore num1. This one I'm going to call TB underscore num2. I click this label. Here's where I put in my answer. So let me call that LB for label underscore answer. Now I'm going to double click button 1. I put my code in. So I declare a variable num1, num2, and the sum. We'll add them together. Num1 is going to equal to int 32.parse. And then tb underscore num1.text. Don't worry about the syntax here. Same way with tb underscore num2.text. I want to add them together. So I'll say the sum is equal to num1 plus num2. Then I want to write that back out to the screen. So I'll say lb underscore answer.text is equal to the sum. And then toString. Yeah, it doesn't look something about that. There. Wanted the beginning parentheses and closing parentheses. So let's run this. Goal of this class is not for you to learn Visual C# at all, so don't sit there and think you have to. I just wanted to show a comparison. And what numbers were they adding together here? 4 and 6. So I put 4 in here, put 6 in here, and I click the button 1. It says sum is 10, which makes sense. 4 plus 6 is 10. That's an example of a high-level programming language. The book talks about these different types. This is a low-level programming language. Now, we won't cover everything here, but we'll start down here at the procedure. This is a register, the R0, R1, R2, and R3, and it's putting a piece of information there. Might be setting a value. It might be calculating, doing an add, but it's setting those. So this is in register 0, it's putting 0. This one says in register 4, now register 1, we're putting 4. This one says in register 2, we're putting 6. We're adding them together and putting the result in something. And then that's it. I struggled with this earlier today. When I was going through and modifying this, I wasn't sure which one should go first. This is add, and then R3, R2, R1. The order of that does matter. What this is doing is it's retrieving the values from register 1, register 2. It's adding them together and then putting it back into R3. And then down here at the end, just some more generic stuff you need to have your code run at this point. Now, if I wanted to make a change, then I could modify these values. But first, let's run this again. Debug, start debug session, click OK. No debug, run. Over here in register 1, you see it now contains 4. Register 2 contains 6. And register 3 contains A. That's weird. A. Well, we're adding together 4 plus 6, which is 10. And for our number system, we have to have a single character. So this is base 16, and the number 10 is A in base 16. You see the rest of these are all zeros. 14 has a value in there, which has to do with a different program, different set of circumstances. Grab a drink here. Does this look very user-friendly? LDR, R0, comma, equals, and what in the world's all this saying? No, it doesn't look user-friendly. This is called a low-level programming language. So let me go back to reset that. All right, let's stop it. Resetting the CPU, what that does is it clears out your registers. And if I come over here to main.s, let's think about how to subtract two numbers. This is the part that I was struggling with. I'm putting I'm putting the value 4 in R1. I'm putting the value 6 in R2. Well, to subtract it, let's leave that alone, and I'll put a subtract here. I'll put my result in R4, register 4, and I'm going to subtract, what am I going to subtract? R2 minus R1. So I'm guessing I put R2 first, then R1 second. Save that. I'm going to right-click on target 1 and say rebuild all target files. So you don't need to rebuild all of them in every case. Then I'm going to go to do my project. Debug. And you see how there's a start-stop debug session. I gotta make these bigger. Now into the debug, after I've started, did a start-stop debug session, I can click the run. Now I got over here, register 1 is 4, register 2 is 6. Makes sense. And then in register 3, it has A. 4 plus 6 is 10, and 10 in hex is A. Over here, we got this, which is 2. And what it actually subtracted is it took R2 minus R1. So that's how that subtract command works. I'll go ahead and stop debug session. Click my main. Let's say I want to add 3 numbers together. Well, not so easy, is it? 3 numbers. Let me get rid of this R1. So we're going to add numbers 8, 12, and 14. We're going to see an issue. Now here I want to add 2 of them together. So, oops, one more down. If I add R1 and R2, it's already set up for that. Puts it in R3. I don't want to put it in R3. I already got data in R3, so I'll do an R4. Then I'm going to take the value that's in R4 and I'm going to add it to R3. And I'll get rid of the subtract right here. Think what this first add is doing. It's going to retrieving the values from R1 and R2, which are 8 and 12. Going to add them together, gives us 20, and put the value here. Now down here, this is going to retrieve the values of R3 and R4. And R4, we already calculated in line above it. So then it just goes and gets R3, which is 14. And then gets a value of R4, which 100 and some. 100 and some. No, not R4. R4 is R2, 1 plus 20. Not 100 and something. And then adds those together. So I should give us 34. I'm going to have to make this bigger. I'm just having the hardest time. There. Now I can see good. It's just blurring together. Now let's see what this gives us. So I do a debug, start debugs. Actually, I need to rebuild it. So let me do a debug, stop debugging. We're here to target. Rebuild all target files. Then I'll do my debug, start, stop, debug session. Then I'll do my debug, run. Okay. Now I can click main here to see my code. R0. I didn't put anything in R0, and it says it's 161. I expect that's left over. We got R1, which is 8. R2, which is C, which is 12. And next one, which is R14, which is E. Okay. And now for R4, I add the R1 plus R2, which would give us 20, which gives us 1,4. And in hex, that is 20. We're going to talk more about that. So that's working. And then this one down here is taking R4, which is 20, and adding R3, which is 14, which is 34. Let's see, 32, 34. And 22 is the hex equivalent of 34. Okay, so that's working. So I'm going to, again, reset CPU would reset this to 0 so you could try it again. So you could run it. But I'm going to do a debug, start, stop debugging. And I got my main S here. By the way, if you look at these other files, you just double click on them. And you can see all what's in those. Does it look trivial? No, it's kind of complex, isn't it? Okay, so back to main here. Let me close this out. There's close project. Now over here, I got my program 2 that I've been working with. You see the dates here correspond. It's got a lot of different files under there. What you're going to turn in for your projects is you go back to the main folder, in my case, assembly language. You find program 2, and you right click on that, and you're going to, let's see. There to send to, and then you choose compressed zip folder. Then you press enter, and you see it's program02.zip. Now, if you don't see the zip on there, within your file explorer, if you do your view, you want to have file name extensions checked. And you'll turn this in. If you turn in just the one file, then I will not have enough to actually test it. So I need all of those files. So when I open up the project, then it has everything contained within that one folder. Make sure you copy those 5 files each time you create a new project. Okay, so that's let me get back there. Under week 1, 116 to 120, you'll see all these information. But down here at the bottom, you see Project 101. Create a Hello World project, zip it up, and upload the file. I do not mean to have it print the Hello World. I mean the Hello World is just what we just created. So you don't have to make any changes at all to that program. Just turn it in as is, and that shows me that you know what to turn in and that you got it configured correctly. Okay, we're going to talk a little bit about the book. We've been going for about an hour now, so I'm going to stand up for a few minutes and take a little break. Hi, Tara. Let's see. Notepad. Tara, you might need to enable your audio. You put your mouse over the bar and choose audio. And I think it says connect via computer. I believe is the wording. Bar might be at the top. It looks like you shut your video off. The audio should be right next to it. think she left. Let's see if she reconnects. I'll go ahead and start again, and then maybe Tara might connect. First day is always kind of iffy on that. I needed to get up. I was getting a little sleepy on that. Assembly language is not the most exciting part. Now, I should mention to change a project, you just do project open project, and you can change it to whatever folder and open that up. And then you got your files back. And your main one you change is always main.s. And you just have to handle it accordingly. Like if I want to add together the numbers from 1 to 4. Yeah. Put 1 in R1, 2 in R2, 4 in R3. Those are registers. Now notice you only have so many registers. When we were debugging, we didn't have 100 registers. So you're limited. You kind of move things in and out in order to work with it. Okay, so I'll come down here. And I'm going to add together R1 and R2 and put it into R4. Then I'm going to add what I just put in R4 with R3 and put it in R5. Okay, so this should get the R1 here and the R2 here. 1 plus 2 should give us 3. So when this is done, R4 should have 3. So then down here, this is pulling 3 that we currently have stored in R4, and it's pulling R3, whatever we had in it was 4. So we got, okay, 3 plus 4 gives us 7 then. Okay, so if I right-click on the target, and I say rebuild all target files, and then I'll choose debug, stop debug session. And do a debug run. Go back to my main.s. R1 contains 1, R2 contains 2, which makes sense. That's what we put in there for these 2 lines right here. We then put 4 in R3, which is this next one, so that makes sense. And then we added together, that's this right here. We added together R1 and R2, which contained the values 1 and 2, which gave us 3, and we put that in R4. And so then we take the value of R4, which is 3, and the value of R3, which is 4. That seems backwards. And of course, 4 plus 3 gives us 7, and that's why we got 7 here. Now, not every register can be used for your purpose. It's perhaps being used by other other processes. Okay, so I'm going to do a debug and start stop debug session. And I'll do a close. Keep wanting to close project over there, and it's under project, close project. Okay, we're going to talk about the book a little bit here. Because that's the second project we have on there. So on page 10, complete the problems, 1.1 through 1.8. Obviously, if you don't have your book yet and it takes a while to arrive, I'll work with you on due dates. So you just have to ask. Some of this I'm going to read to you. Some of them I'm just going to refer to. It says, any automatic machine that performs a sequence of actions in order to execute a complex task may be referred to as a processor or a processor system. If the sequence of tasks is defined by a list of encoded instructions, system is a programmed one, and the list of instructions is a program. We got today the names processor and processor system. This is under 1.1. Today the names processor and processor systems are usually applied to digital electronic systems whose actions are determined by programs held in high-speed memory. The systems are stored programmed digital computers. Program is a list of patterns called operation codes, opcodes, instruction codes, or code numbers. And we've already seen that with the assembly language program we worked on. Talks about the difference between hardware and software. That's kind of obvious. It says over here, even a simple program has a large number of instruction codes listed in the order in which instructions are to be performed. Look over here. This library that we needed. It's got a lot of commands. That's doing a lot of different things, isn't it? And this is simple, adding some numbers together. Now over here, we added two numbers together, and it was just two numbers. It wasn't three numbers like we just did. But I could add a third number here and not have it much more complex. Now the higher level, and they talk about the different types of languages in here. There's high level programming and low level. High level is when you don't worry about the hardware at all. And that's why I did it here. I wrote this program to add these two numbers together. I didn't worry about registers. Couldn't even tell you how many registers are on the machine. You don't care. You use variables to keep track of your information. Over here, I had to, of course, this was already done for me, but I had to really worry about the machine state. All the different specifics for the machine, the heap memory, stack memory, IRQ handler, so forth. Over here is shorter. Still wasn't necessarily simple though you might make the argument that's less code, which I would probably agree with. But again, if you get anything a little bit more complex than that, then you'll find you have to use tons of code. How the programs talk is they talk via machine code. Machine code is specific to that architecture. You got for high level language, you got a compiler, and that takes your program and puts it into a format where the machine can understand it. And the book goes over that in a lot more detail. The low level language, like assembly language, You might say, well, why use it? A higher level is less code. It's easier, a lot easier. Why would we want to use this? Since this is at the hardware level, then it runs faster. It doesn't have a lot of the overhead that the other language would have, C sharp. Used to be, and I'm not sure if it's still true or not, but it used to be that they wrote parts of video games in assembly language. For example, if you had a game where you had 20 characters go on the screen, and the game would just almost look like it's freezing, going so slow like that. Well, that's a performance issue. They used to write some of those in assembly language. By writing in assembly language, they were able to get that performance boost. With the assembly language, we use just the bare minimums that we need. We don't bring in a lot of extra items. Over in a higher level language, these up here, the C sharp, has a bunch of using statements up here. This is bringing in pre-written code, and so we can use it. Let's see if I right-click on that. Let me see if I can go to the implementation. I think it's implementation, not definition. No. We go to definition. But all of this that is coming in is bringing a bunch of code in with it. So there's a lot of overhead behind this. This uses an object-oriented type of concept, and it's bringing in a lot of code. Okay. Talks about main tools in assembler, which allows programs to be prepared as a list of text statements in a low-level language, an assembly language. This particular book here focuses on the ARM. So that's down here on the bottom of page 2. They talk about ARM. Language described here is for systems using the ARM core designed by ARM Holdings plc as the CPU. The ARM core belongs to a class of CPUs known as RISC machines. You might have heard that before. That's kind of a common term you see. And over on page 3, it talks about where it's used at. It says the ARM core is used as one element of complex integrated circuits built in electronic products. For example, a majority of cell phone handsets contain at least one ARM core. Depending upon what kind of machine architecture you have, you'll need to learn different assembly language, assuming it has it. So do not think that the assembly language you learn here you can go and apply to other architectures. You can't do that. Talks a little bit about memory on page 4. Talks about page 5. Talks about data storage. Transfers to and from the CPU is on page 7, 1.5. You'll notice that some of these have different commands where you'll bring things into registers. So that's what they're talking about. You have to bring something in, load it in your register, and before you can use it. And I'm not going to go over all this in the book. Leave that for you to read. And there's 8 relatively simple questions there. We're going to mainly focus on the conversion of numbers. Grab another drink here. close that down. And can you hear me, Tara? I don't think so. Oh, hi. You're muted. To unmute yourself, you just press your space bar, and then you can talk. And then,
Hello.
hi.
Can you hear me?
I can hear you.
Hi. Well, I'm worried because I have kids, so I'm trying to keep it muted.
Oh, now I learned that earlier. A student taught that to me. Is that
See?
yeah? When you want,
I have nosies.
yeah, when you talk, you just press your space bar, and that unmutes you. And then when you lit up on a space bar, you're muted again. I didn't know that feature existed, so that works out really good if you got a lot of background noise and so forth. Now, what I've done so far is I showed how to set up the Kyle UVision 5, and that's for creating assembly programs. And so that's pretty straightforward. If you watch this video here, he walks you through how to do it, or if you watch the YouTube video that I'll put up later, you'll see how to do that. Then I talked a little bit about what's in the book here, and I'm getting ready to look at these conversions and talk about those. Data is stored in different ways in computers. We have our digital storage, and we can't necessarily use our base 10 that we're used to. Our base 10, and I need to bring in a new tablet, so I'll go ahead and apologize. This is not going to be great. Our base 10 is 0, 1, 2, 3, 4, 5. Let me just use my mouse. Actually, I might be able to type that. So what we're used to is base 10, which uses the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. A digit can only be one character. Computers use binary, which is base 2. And the only digits you can use are 0 and 1. This corresponds to gates where you have something on or off. So it's just the real core design of digital devices. Now, an example is 37, and I'll put a D here for our base 10. That's just our standard. And 110011, and this is our binary. Now we're going to want to convert back and forth between them. It's a fairly simple process. There's problems in a book that ask you to do this. I put worksheets out to do it. So let me go over to Blackboard. Now here, this first worksheet is binary to decimal conversion.pdf. So let me open that up. These are in binary. We want to convert them to decimal. When I say decimal, that's our base 10. Well, I got somewhere. I got Word documents that'll help us with this. And let me see. There it is. In this case, we're going from binary to decimal. And I'll upload these. I haven't uploaded those yet. Personally, I think it's probably easier if a person could laminate these and work with them in that way. Okay, so binary to decimal. It says decimal numbers less than or equal to this. Now, when we're saying binary, those are powers of 2. 2 to the 0, 2 to the first, 2 squared, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth, 2 to the seventh, 2 to the eighth, 2 to the ninth, and so on. So if I needed a bigger number, I'd go to 2 to the 10th, 2 to the 11th, 2 to the 12th. Now, anything to the 0 power is equal to 1. 2 to the first is 2, 2 squared is 4, 2 to the third is 8, 2 to the fourth is 16, and so forth. Now we're going to take step 1, write down the following chart, which we already have. Note if necessary, increase the powers to handle the number. And then it says write the binary number in the blanks. So starting from the right side, we got 1, 0, 0, 1. So we've got 1, 0, 0, 1. And 0, 1, or 10, 10. So 10, 10. Okay, so we just wrote down our number in the blank, making sure it's right aligned. You don't want to left line it here, but you want it from the right side. Then it says, multiply the numbers in the blank by the corresponding number in the bottom row and add these up. Which means we're going to take the number right here, this 1, and we're going to multiply it by this 128. So you multiply the number in the blank by the number that's down here. So we're going to have 1 times 128 plus, and then we take the next number, which is 0, and we multiply by the number here. Now, obviously, whenever it's a 0, 0 times anything is 0, but I'm going to go ahead and write it down. 0 times 64. Then you take your next number, which is a 1, and you multiply it by the number down here, which is 32. Then our next number, which is a 0, times the number down here, which is 16. So we got 0 times 16. Then we got our number here, the 1. Now we're going to multiply by the number down here, which is 8. So I got 1 times 8. And I keep going. So I'm taking this 0 here times the 4. Plus 0 times 2 plus 1 times 1. That 1 times 1 is coming from these right here. If I get that to go away. There. So that 1 times 1 is coming from here. Multiply the number in the blank by the number that's in the bottom row there. Now, as I'm going through this, if you have any questions, be sure to ask. If you want to see more examples, be sure to ask. So here, 1 times 128 is 128. 0 times 64 is 0. 1 times 32 is 32. 0 times 16 is 0. 1 times 8 is 8. 0 times 4 is 0. 0 times 2 is 0. 1 times 1 is 1. Let's see, 128 plus 32 plus 8 is 40, plus the 1 at the end equals 128 plus 41 equals 169, assuming I added all my numbers correctly. Which means that this number right here in binary is equal to 169 in decimal. So you put 169 in this blank right here. Now, if you're using that sheet, you can do it that way. But otherwise, you write down this this number. Let me show that. I think I can do this. And I'm going to keep my resize. There. This next number is 0, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0. So write down our number. Then we want to write down a number that's on the bottom row here, starting with the far right. So it's 1, 2, 4, 8, 16. It's multiplying by 2 each time. So this is 1. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. Times another 2 is 16. Times another 2 is 32. Times another 2, which is 64, and I apologize for my writing here. I'm using a mouse. Times another 2, which is 128. So now we're going to take each number on top here times the number we just put down. So this, I wonder if I can type it. I'd have 0. 0 times 128. That's taking this number here times 128 plus 0 times 64. You actually don't need to worry about the zeros at all because they always drop away like what I'm showing. 1 times 32, 1 times 16, 0 times 8, 0 times 4, 1 times 2, 0 times 1. 0 times 128 is 0, plus 0 times 64 is 0, plus 1 times 32 is 32, plus 1 times 16 is 16, plus 0 times 8 is 0, plus 0 times 4 is 0, plus 1 times 2 is 2, plus 0 times 1 is 0. 32, 48, 50. So 0, 0, 1, 1, 0, 0, 1, 0 binary is equal to 50 in decimal. And oftentimes you put 50, or you put the B after that first number to indicate binary, and after the 50 you put a D to indicate that's the decimal. Now it's pretty easy to check these as you go through, because if this is 2 to 0, which is 1, 2, 4, 8, 16, 32. So you got 32 plus 16, which is 48. And over here, this would be our 2, so that's 50. So that checks. Is there any questions on going from binary to decimal? Okay. We'll close that. And we'll go the other direction. Clear this off. And that was our first one. That's binary to decimal conversion worksheet. We're going to go from decimal to binary now. So the other direction. So we're starting with our decimal. We want to convert that to our 1001100 format, our binary. So let's start at 55. And we got 55. And decimal to binary, decimal to binary. Here it is. Okay, so step one, write down the following chart. So you have that written down. And then step two says find the initial key number. The key number will be the number being converted. So initially our key number is 55. So that's our key number. Then it says, old style, divide the key number by the number on the bottom row of the step one that is less than or equal to the key number. What in the world does that mean? Well, it looks like we look for our first number that's less than or equal to 55, our key number. 512 is not less than or equal to 55. 256 isn't. 128 isn't. 64 is greater. It's not less than or equal to. 32 is the first number that's less than or equal to 55. So what we're going to do with that 32 is we're going to do old style division. And I was hoping my tablet would work, but okay, so that's our key number. So we're going to take our 32, and we're going to divide that into 55. Well, 32 doesn't go into 5, but it'll go into 55, goes into it one time. Then remember, you take whatever numbers here, you multiply by what's out in front. 1 times 32 is 32. And then I want to subtract that. 5 minus 2 is 3. 5 minus 3 is 23. Now this is going to be our new key number. And that one we just found right here, this is going to go above the 32. So if I come over here, here's a 32. I'm going to come up here and I'm going to put a 1. Now this talks about if the key number is not 0, then go back to step number 3. So we're going looking for the next number that's less than or equal to our current key number. Our current key number is 23. The next number that's less than or equal to that is 16. So we're going to divide our new key number by 16. So 16 goes in 23 one time. 1 times 16 is 16. Subtract those. 23 minus 16 is 7. And this is my new key number. And this 1 right here goes above the 16. So here's our 16. The 1 goes above that. So I come here and I put a 1. Now this 7 is our new key number. So we're looking for the first number that's less than or equal to that. 8 is not less than or equal to that. So I skip that. 4 is the first number that's less than or equal to our new key number, which is 7. So I'm going to continue this process, come up here, and I'm going to divide the new key number by 4. 4 goes into 7 one time. 1 times 4 is 4. 7 minus 4 gives us 3. And this remainder you see right here, this 3, is our new key number. And we're going to take this number up here, this 1, and we'll put it above the 4. So I come here, above the 4, I put a 1. Now keep in mind 3 is our new key number, so I'm looking for the first number that's less or equal to that, which would be 2. And I'm going to divide my new key number by 2. Two goes into 3 one time. 1 times 2 is 2. Subtract that. 3 minus 2 is 1. And this is going to be my new key number here. And this number up here, this 1 is going to go above the 2. So I come here and I put a 1 here. So then I'm looking for the next number that's less than or equal to this key number, which is 1, which would be right here. So again, I'm going to do old style division. I'll take that 1, divide by the 1. 1 goes in there 1 time. 1 times 1 is 1. Subtract that. 1 minus 1 is 0. And this 1 here goes above the 1 on my sheet. So I have a 1 here. Now it says if the key number is not 0, well, our key number is now 0. This is our key number. Your remainder is always your key number. So it is 0. So we go to step 5. Step 5 says put zeros in the empty blanks. It says but no leading zeros. So I'm put a 0 here. And I don't need to put zeros here. And this would be our answer. Now, we start off with 55. Now, it's easy to check it. You take the number here times the number down here. So you got 1 times 32, which is 32. You got 1 times 16, which is 16. 32 plus 16 is 48. 0 times anything drops away. Here we got 1 times 4, which is 4. What did I have? I had 48 plus 4 is 52. And then 1 times 2 would give us 2, and that gives us 54. Wait a minute. Oh, no, I forgot this one. It does give us 54. But this one we've got 1 times 1, which will give us 1, and then 54 plus 1 is 55. So it checks. Grab a drink here. You want to see another one of those? I might don't forget to unmute yourself if you talk. But otherwise, I'll assume that you didn't have any questions on that. But I might show one more just to solidify that. So let me get rid of these numbers, if I can figure out how to do it. And again, we're going from decimal, what we're used to using every day. We're converting that to binary, so a computer could use that. And let's see. Okay, so let's take a look at our next example. 147. Okay, so to begin with, your starting number is always your key number. It goes without saying. And from our sheet, it tells us to find initial key number. The key number will be the number being converted. And that's what we just said. And then you old style divide the key number by the number on the bottom row of step 1 is less than or equal to the key number. So we're looking for the first number that's less than or equal to 147. 256 is not less than or equal to 147, but 128 is. So we're going to divide by 128 and see what we get. So we got 128. And dividing that into 147. 128 goes in 147 one time. 1 times 128 is 128. If I subtract those, I brought a calculator with me, just because I'm not that great at some of this basic math. 147 minus 128, 19. Now, when you divide by that, your remainder is always your new key number. So 19 is my new key number. The number up here is what goes above the 128. So we're going to put a 1 above the 128, which would be right here. Now, our key number is 19. We're looking for the next number that's less than or equal to 19. 64 is not less than or equal to 19. 32 is not less than or equal to 19. 16 is less than 19. So we're going to work with 16. So we're going to take the 16, and we're going to divide that into our new key number. So 16 goes in 19 one time. 1 times 16 is 16. Subtract those. 19 minus 16 is 3. And this is going to be our new key number, this 3. The remainder is always your new key number. And whatever number we put up on top, in this case the 1, is going to go above the 16. So I come over here, above the 16 I put a 1. Now our new key number is 3, so I'm looking for the next number that's less than or equal to 3. I got 8, that's not less than or equal to 3. I got 4, that's not less than or equal to 3. I got 2. 2 is less than or equal to 3, so I'm working with that. So I'm taking my 2 from that chart, and try that again. So 2. And we're going to divide that into our new key number, which is 3. That's right down here. 2 goes into 3 one time. 1 times 2 is 2. And if I subtract that, 3 minus 2 is 1. Now this new remainder is our key number. This 1 here goes above the 2. So come over here and put a 1 above the 2. So then I'm looking for the next number that's less than or equal to our key number. Key number is now 1. And there's only one left that's less than or equal to, which is right here. So I'm going to use that. I'll do 1. I'll divide that into 1. Goes in there 1 time. 1 times 1 is 1. Subtract that. And we get a 0. Now this would be our new key number. This is 0. So then we're going to see we're done. And then this 1 here, we're going to put above the 1 here. So I'll put a 1 here. Now this is 0. So I come down here. If the key number is not 0, then go back to step number 3. And that's what we've been doing this over and over. And then if it is 0, you come down here and you put zeros and empty blanks, no leading zeros. So these empty blanks I have here, I want to put zeros in there. So that would be our answer for that problem. What was it, 147? So 147 decimal is going to equal to 1, 2 zeros, 1, 2 zeros, and then 1, 1. I'll put a B there to indicate binary. And that's how you go from decimal to binary. Now, I know you may not have your book yet, but in the book, they refer to binary numbers. They also refer to hex numbers. I'm going to cover octal if I have time. I think I will. But first I want to cover hex, because that is in the book, and I don't see octal. Binary is how digital devices are designed. 1 being the gates open, 0 being the gates closed. Now it's interesting, you don't got 1s and 0s passing through your electronic device. Like if you look at this calculator here, you don't got 1s and 0s flowing through that. What that's happening is voltage is going through it. And if the voltage is so high, then it's considered a 1, or the gate can be open. If it's 0, then it's the voltage is lower. I thought that was interesting. There's error correction built into it, so it's not as flaky as it sounds. But if your voltage is skewed a little bit, then it will be, instead of a 1, it might be a 0, or instead of a 0, it might be a 1. Okay, let me clear that off. I'll go ahead and close this, and we'll talk about octal. I started looking at time and realized, I got time to cover octal. Okay, so our next sheet, let me close that one. Skip the hex. I'm going to go to decimal to octal. So this is in decimal, and we want to write it in octal. There are certain devices that store their data in a format that's octal. Hex is something you run across in computer science. So let's first talk about what in the world's octal. There it is. Octal is base 8, which means the only digits that you can use are 0, 1, 2, 3, 4, 5, 6, 7. Now it seems weird, base 8, but it doesn't go up to 8. This talks about how many digits there are total. We got, if you go through and count here, not that I can highlight it, but we got 1, 2, 3, 4, 5, 6, 7. There's 8 of them. So if I had a example, if I had 8, 1, 2, and I said this was octal, like I put an O here to indicate octal, that wouldn't be right because you can't use an 8. So that could not be octal. On the other hand, if I had this and said that's decimal, that's possible because our decimal representation goes from 0 to 9. Those are all the digits we can use. Okay, so this decimal to octal, we'll start with 31. So we got 31 and decimal. And we want to change that to octal. Well, you just really follow the sheets. We're looking for the sheet that says decimal to octal. So come over to the sheet for decimal to octal. And this tells me what to do. It only handles up to this number. This first blank is 8 to the 0. Anything to the 0 power is always equal to 1. This is 8 to the first, which is 8. 8 squared, which is 64. 8 to the third, which is 512. 8 to the fourth, which is 4,096. And 8 to the fifth, which is 32,768. And so on. If I kept on going with new blanks, I have 8 to the 6th, 8 to the 7th, 8 to the 8th, 8 to the 9th, and so forth. It says, if necessary, increase the powers to handle numbers. So if you're working with a number bigger than 32,768, you'd want to put more numbers to the left. Now it says, find the initial key number. The key number will be the number being converted. So our number being converted was, what's it, 31? Yeah, 31. So 31 is our key number. Step 3, old style divide the key number by the number on the bottom row of step 1 is less than or equal to the key number. So our key number is 31. We're looking for the first number that's less than or equal to 31. 64 is not less than or equal to it, but 8 is. So we're going to divide by 8. So with old style division, you're going to take 31, divide by 8. 8 goes into 31 3 times. So 3 times 8 is 24. Subtract that. 31 minus 24 is 7. And 7 is going to be our new key number. And this number up here, the 3, is where we're going to put above the 8. Now here's our 8, so we'll put a 3 up here. Now this is our new key number, so I'm looking for the next number that's less than or equal to that. Our next number that's less than or equal to that is 1. So we're going to divide by 1. One goes into 7 7 times. 7 times 1 is 7. I want to subtract that. That gives me 0. This is going to be my new key number. Now this 7 here, we're going to put above the 1. So I'll put a 7 there. Now our steps would say, since our key number is now 0, comes down here. If the key number is not 0, then go back to step number 3. It is 0. So we're going to put zeros in empty blanks, but no leading zeros. So I don't want to put zeros here, so the answer would be 37. So in response to our question, what's 31 decimal? Where's my sheet? Oh, there it is, 37. So that's equal to 37 octal. And I put an O here for octal. Made it a little bit smaller. You want to make sure it's not doesn't look like a 0. Okay, let's look at going the other way. Okay, so I'm going to close this. That's decimal to octal. So now we'll look at octal to decimal. Now these are in base 8, octal, and we want to convert them to base 10. You'll notice looking through all these, they don't have an 8, they don't have a 9. They can't. So that's octal. So this is 175 octal. 175 octal. I'll put a little O there for octal, make it smaller this time. And close that. And octal to decimal. Right here. Okay, step 1. Write down the following chart. And it's just like before. It's 8 to the 0, 8 to the first, 8 squared, 8 third, 8 to the fourth, 8 to the fifth. Necessary increase the numbers to handle your number. Step 2, write the octal number in the blanks. Our octal number was 175. So I'll put 175. Notice I right align it again. Then step 3, we're going to multiply the numbers in the blank by the corresponding number in the bottom row, which means we're going to take 1 times 64 plus 7 times 8 plus 5 times 1. And we're going to add those up and see. So 1 times 64 plus 7 times 8 plus 5 times 1. So we got 1 times 64 plus 7 times 8 plus 5 times 1. 1 times 64 is 64 plus 7 times 8 is 56 plus 5 times 1 is 5. Which gives us 125. So 175 octal is equal to 125 base 10 decimal. Excuse me. Is there any questions on those conversions? Okay, let's look at base 16. This is hexadecimal. Hexadecimal is base 16. Now, base 16 has the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, when we looked at binary, that was base 2. And we had 2 digits. We had 0 and 1. When we looked at octal, which was base 8, we had 0 through 7. We had base 8, you had 8 digits. So base 16, we should have 16 digits. We're missing some. You see, we go from 0 to 9, that's 10. So we need 6 more. How they handle that with hex is they use letters. So A is going to represent 10. B is going to represent 11. C is going to represent 12. D is going to represent 13. E is going to represent 14. And F, let's go down here. E is going to be 14. And F is going to be 15. Remember, base 16, we go from 0 to 1 less. So it goes 0 to 15. So a perfectly acceptable number in hexadecimal would be AA1 BC. And I'll put a little h there for hex. So that would be an example of a hex number. Well, we're going to do the same thing. We're going to convert back and forth on these. So let me bring up the appropriate sheets. Decimal to hex. Okay, decimal to hex, and come over here. Decimal to hex. So we got 415 in decimal. We want to change that to hex. So let's write that down, 415. And you see here where it's coming from is what format's in. So this is decimal. I'll put a little d for decimal, I guess, so we can easily see it. We want to convert that to hex. Well, our sheet says, and no, by the way, notice this is 16 to the 0, 16 to the first, 16 squared, 16 to the third, 16 to the fourth, 16 to the fifth, and so on, and then numbers below it. Says, find initial key number. Key number will be the number being converted. So to begin with, our initial number, 415, is our key number. Then we're going to look for the first number that's less than or equal to 415. 65,536 is not less than 415. 4,096 is not less than or equal to that. 256. 256 is less than or equal to 415. So I'm going to do my old style division. I'll take 256 and I'll divide that into 415. Now, 256 goes into 415 one time. 1 times 256 is 256. Now let's subtract that. So 415 minus 256, and I get 159. Now this 159 is going to be our new key number. And this 1 you see up here is going to go above the 256. So I'll put a 1 there. Now our new key number is 159, so I'm looking for the next number that's less than or equal to that, which would be 16. So I'm going to divide 16 into 159. $16 doesn't go into 15, but it does go into 159. Goes into it 9 times. Then you take your number on top times number at the front. 9 times 16. 144. Subtract that. 9 minus 4 is 5. 5 minus 4 is 1. And this is going to be our new key number. And the 9 you see here goes above the 16. So put a 9 here. Our new key number is 15, so I'm looking for the next number that's less than or equal to 15, which would be this 1. So I'm going to divide 1 into 15. One goes into 1 one time. 1 times 1 is 1. Subtract that, and I get a 5. 1 goes into 5 5 times. 5 times 1 is 5. 5 minus 5 is 0. And this is my new key number. So this 15 goes above the 1. So this 15 goes here. Now, this 15 here, you can't have. It's supposed to be a single digit. But remember, 15 is equal to F. So instead of putting a 15 there, we put F. So this is the hex version of that, 19F. So for this answer, 415 decimal is going to equal to 19F hex. 19F. And I'll put a little h for hex. And that'll be your answer. A lot of old style division on these. Okay, one more conversion. That was decimal to hex. So we want hex to decimal. So hex to decimal. Let me bring up one of the sheets. Hexadecimal. So here's our hexadecimal. And we're going to start with 11E. We want to convert this, which is hex, to decimal. 11E. Okay. Not if necessary, increase the powers. Write the hex number in the blank. So we got 11E. So I put a 1 here, put a 1 here, and I'll put an E here. Multiply the numbers in the blank, so numbers we just put here, by the corresponding number in the bottom row. So we're going to take 1 times 256. Then we're going to add 1 plus 16. And then we're going to add E times 1. So 1 times 256 plus 1 times 16 plus E times 1. Okay, so let me write that out. 1 times 256 plus 1 times 16 plus E times 1. E. Well, that doesn't help us very much. What in the world's E? Well, remember down here, we said E is equal to 14. So let's plug that in. 1 times 256 plus 1 times 16 plus E, which is 14 times 1. So I got 256 plus 16 plus 14. 16 plus 14 is 30, so it's 286. So 11E in hex is equal to 286 in decimal. And that's how you do that conversion. It's assuming I haven't made a basic math error on any of this. This is used in some networking, if you're wondering. You'll see it throughout the book where they refer to hex, refer to binary. IP config. I think that's what it is. As you look at some of the addressing here, this is in hex. See FE80C01. Nowhere do you see anything above an F. So this is in hex format. With hex format, you can actually represent a larger number with fewer digits, which is one of the benefits of it. Anyway, that's hex. Now I'm going to add those sheets onto here. So let me put that on here. And let's see. There it is. Step by step. Binary to decimal, decimal binary, decimal to hex, decimal to octal, hex to decimal, octal to decimal. 1, 2, 3, 4, 5, 6, 7. Something's wrong. Okay, that's a PDF. 1, 2, 3, 4, 5, 6. Okay, I'm not going to worry about that PDF. Click open on that. You see the new ones down here, and I'll just go ahead and click submit. And those will be the worksheets you'll use to do these homework problems up here. Okay. So you see those, these up here are what you're to do for the homework. Put it into a Word document. If you want to just write down your answer, that's fine. You don't have to show all your work. If you struggle with any of these, you can email me. Say, hey, I can't figure out problem number 5. And I'll work it in the YouTube video format. At home, I got my tablet working. And that might help clear the block you've come across. Even if you don't have your book, you should be able to do 1.1-01 and 1-03. So if you don't have your book yet, then let me know, and I'll work with you on the due date for 1-02. One thing out of the book I'll mention. Let me clear this off. They talk about base 3. Now, base 3, let me clear this. I don't think it has a name. First off, remember base 8, octal. Base 8 went from 0, 1, 2, 3, 4, 5, 6, and 7. These are the only digits we could use. When we're talking about base 3, if it has a name, you can only use the digits 0, 1, and 2. So that's all you can work with. It's pretty much exactly the same idea as what we did before, but everything's in base 10. So you're going to have your blank over here. You have that. You have one here, one here, one here, so forth. And this will be 3 to the 0 power. The first one's always a 0 power. Anything to the 0 power is 1. This will be 3 to the first, which is 3. This will be 3 squared, which is 9. This will be 3 to the third, which is 27. This will be 3 to the fourth, which is 81. Beyond that, it's the exact same principle as the other conversions we've just done. So in the book, I think that's problem number. They got a lot of different bases. Problem 1.4. They got base 2, base 3, which is what we got there. They got base 5, which means this would be 5 to the 0, 5 to the first, 5 squared, 5 to the third, 5 to the fourth, and so on. They got base 8, which we looked at, base 9. This would be 9 to the 0, 9 to the first, 9 squared, 9 to the third, 9 to the fourth, and so forth. Base 12, 12 to the 0, 12 to the first, 12 to the second, and so on. So I guess there's a couple of different problems that deal with the different bases. Now I'm going to go ahead and stop the recording there. I'm done with the material. These problems here are due by Sunday at midnight. You shouldn't have any trouble getting at least like the first one and third one done, like I said. And again, if you don't have your book, let me know and I'll work with you on the second one. But if you have any questions, feel free to ask. And again, I'll be on every Wednesday from 4 to 6:45. So take advantage of that. You can sign on. You can interact if you want, ask questions, or you're welcome not to sign on and you watch a YouTube video. Be sure to watch a YouTube video. In the YouTube video, I may make announcements like this is due on Sunday. If you don't watch YouTube video, you won't catch that announcement. So I'll go ahead and stop the recording.